Hello everybody, welcome to the walkthrough video of Bulletproof Penguin by TryHackMe. My name is Rushain from RootHack. In this room, we have been given a total of 10 tasks. We are dealing with an old Linux server along with a vulnerability scan report made against the server. In each task, we are supposed to implement solutions or patch them to each finding given in the vulnerability report. We only have remote access to the server via SSH. The credentials are provided. At the end of each task, we are supposed to use get-flags to get the updated flags. So without any further ado, let's dive in. Okay guys, so in task 1 they have given some information about this remote Linux server like I mentioned before in the intro. By the way guys, I already noted down some information in this text file because it's easy for me to refer. So let's go ahead and ping the target IP and see if it's reachable from the network. Awesome, we are getting some pings. Now let's go ahead and SSH into the server. Alright, we are in. So in task 2, there is a reported vulnerability that says the remote Redis server is not protected with a password. This flow can be exploited by a remote attacker to gain access to sensitive information or modify system configurations. And the solution is to obviously set a strong password. We are going to look for the Redis configuration file first and do the modifications there. So we're going to do a find command in the root directory. Type is a file, name is redis.config, and this bit is included so we don't get any null responses. The results returned and the file path is being found right here. So we are going to attempt and edit the file. In this file, there are so many information obviously, and we are specifically looking for a directive called require pass. There we go. So we are going to uncomment this and include a strong password, but for demonstration purposes, I'm gonna sort of keep it simple. And we are obviously going to save this and exit. And that's it for task 2. So remember, always use get-flags after you have completed each task to get the flag. I'm not going to do that after each task is completed because it's going to reveal the flags obviously, and it is not sort of ethical to reveal on a walkthrough video. So I'm going to keep moving on to each task. In task 3, it reports an issue with the SNMP agent. So Simple Network Management Protocol, or SNMP, is a protocol which can be used by administrators to remotely manage a computer or network devices. There are typically two modes of remote SNMP monitoring. These modes are roughly read and write, or it can be set to public and private. If an attacker is able to guess a public community string, they would be able to read SNMP data depending on which MIBs are installed from the remote device itself. This information might include system time, IP addresses, interfaces, processors running, and so much more. If an attacker is able to guess a private community string, they will have the ability to change information on the remote machine. This could be a huge security hole, enabling remote attackers to wreak complete havoc, like routing network traffic, initiating processes, and so much more. In a nutshell, write all access will give the remote attacker full administrative rights over the remote machine. And our task here is to change the community name in the meantime as a fallback solution until a new monitoring solution is acquired by the company. It says in the task they're trying to implement SNMP version 3 in the future. Right, so we are going to look for SNMP config file and do the modifications there. Alright, we found it. Let's go ahead and edit that. In here, what we are looking for is community, and you can search for it and change it to private if it's set to public. Here we go. As you can see here, it is set to public at the moment, which is making this server vulnerable. Now let's modify it to private. Cool. And that's done just like that. Alright, so in task number 4, in the vulnerability report, it says that Nginx server is running as root, and we are supposed to change the Nginx configuration to run as the existing www-data account. So first of all, we must make sure this detection result is still true. So we go ahead and check which user Nginx is using currently. So we're going to use this command to do that. So if you take a look at the first column right here, in this output, it shows which user is currently using Nginx. The Nginx server shouldn't be running as root, because an attacker could leverage this to gain privileged access to the server by abusing a vulnerable web application hosted by Nginx. There is a possibility this configuration could have been left as root due to testing purposes, and it would have been left there by mistake without doing any changes afterwards. So we're going to look for the config file and make changes just like the previous tasks. File name we are looking for is nginx.config or .conf. Found it. Let's go ahead and edit. Now there's nothing to search here. On the very top in the very first line it says user is set to root. We are going to change this to www dash data. And we are going to save this configuration and restart the Nginx server. Now to check if we got these changes in place, we can run the previous command once again to check if it's there. And as you can see, there we go, the changes are right here. It's running on the new user that we have set. Cool, that's it for this. By the way, you can use get dash flags to get the flag for this task. In task 5, in the detection result, it says the remote host is running a telnet service that allows clear text logins over unencrypted connections. An attacker can obviously uncover login names and passwords by sniffing traffic to the telnet service pretty easily. And in a scenario like this, an ideal solution would be to replace telnet with a protocol like SSH, which supports encrypted connections. But the thing is, the server already supports SSH, and there's no need to keep the telnet service running. And the task says that there's another service is running on port 69, which should be shut down as well. So first of all, let's go ahead and find out what is the service that is running on port 69. So for that, we are going to use this command. Sudo lsof-i:69. It is a UDP node and it's running on TFTP. Well, TFTP is a very simple protocol and it does not provide many of the features of more robust file transfer protocols like FTP. TFTP does not support authentication, encryption, or error correction. But TFTP is very efficient and easy to implement, which makes it ideal for some applications. And TFTP is often used to boot network devices like routers and switches, and it can also be used to transfer configuration files and other small files. And the next port we are going to take a look at is port 23. Typically, SSH runs on port 23. There we go. Now you might notice in the first column for both these results it says inetd. Now inetd is a super server that listens to incoming network connections and starts the appropriate server daemon based on the connection type and the port number. inetd.config file is a critical part of the Linux networking stack. So we should be very careful when we are dealing with it and doing the modifications. Now these inetd services are possibly running clear text services, so we should disable them. Now let's look for the file where it is located. Found it. In this file, clearly we can see there are two green lines. One says telnet, we are going to comment that out. And one on the bottom says TFTP, we are going to comment that out. Now we're going to exit the file, save this config, and restart the service. And the command for that is sudo systemctl restart inetd.service. Cool. Once this is restarted, you can use get dash flags to get the flag for this task. We are going to run the lsof command one more time to see if these ports are actually closed after this config is done. Port 23 does not give any results, and port 69, same, both ports are closed, so this is a success. In task 6, we have been given some detection results for weak key exchange algorithms supported SSH and weak encryption algorithms supported SSH, and also weak MAC algorithms supported for SSH. And our task is to disable all of the reported weak algorithms currently available to the SSH service. Now the severity here is when a server is running weak MAC algorithms, weak encryption algorithms, and weak key exchanges, an attacker can easily break these individual connections. So if these are a threat, we should definitely disable them and adapt more secure encryption methods. So first of all, let's find out what are the key exchange algorithms currently available on SSH. So to do that, we are going to use this command over and over again. Right. Now in my notes, I have some information noted down here for task 6, and we're supposed to take this one out because it's a weak encryption, Diffie-Hellman. Now if you can see here, the first result is exactly that. Next, we'll view what are the encryption algorithms currently available on SSH. Same command, except the last bit should be set to ciphers. Alright, cool. So in this, we have 3DES CBC, AES 128 CBC, AES 256 CBC, and finally we are going to look for MAC algorithms that are weak. Right, in the task we're supposed to remove HMAC MD5 96, and here it is. So let's go ahead and find this config file first. The file we are looking for is sshd_config. Cool, we found the file, and let's go ahead and edit that. Now, first of all, we'll search for ciphers. Cool, so ciphers, MACs, and key exchange algorithms are in these 3 lines in it together. I'm going to zoom out quickly, and so what I'm going to do is I'm going to take each of these and search here and delete it, and we are going to repeat the same for all 5 of them. Cool. And now we have to restart the service in order to take effect and also to find the flags. Alright, in the next task, it says that it was possible to log into the remote FTP service with logins like anonymous and FTP. So basically, when a host provides a FTP service, they might additionally provide anonymous FTP access as well. And under this arrangement, users do not strictly need an account on the host. Instead, the user typically enters a username like anonymous or FTP when it's prompted for a username. And for the password, typically it's prompted, you can enter an email address, but the thing is, there's little to no verification is actually there. And based on the files accessible via this anonymous FTP login and the permissions of this account, an attacker might be able to either gain access to sensitive files, upload or delete files, and modify the existing files on the server. So we are supposed to disable anonymous access to the FTP server to avoid any future data leaks. Now in the detection result, it shows that using the anonymous account, they were able to get the secret file.txt, and they were able to use the FTP login to do the same. And before we do anything, let's test that out. I'm going to a new terminal and FTP into the target IP address. It's asking for a name. I'm going to put FTP. Password, I'm just going to click enter. And it says login was successful. I'm going to use the get command to download this file into my machine. File name is secretfile.txt. And just like that, it is downloaded. We are going to check if the file is there. And there it is, some sort of a string there. So yeah, that was possible. So we are going to go back to the server here, and we are going to disable the anonymous login. First of all, let's find the config file. The name is vsftpd.config. Cool, we got the result. Now we're going to edit that. Now if we scroll down somewhere here, it says allow anonymous FTP, and it's supposed to be disabled by default, but it is enabled, and we are going to set this parameter to no. And we are going to restart this service as well. In task 8, in the detection results, it says the following SSH credentials were brute forced. And it seems like these two accounts are using easy to guess passwords. A hacker could easily launch a brute force attack against them to gain access to the server. So our task here is simple. We are supposed to change the passwords of Mary and Mundra accounts to obviously strong passwords that cannot be brute forced that easily. And also we're supposed to erase these accounts which are inactive. One is Joseph and one is test1. Now this task is pretty easy, so let's go ahead right into it. We are going to change the passwords of Mary and Mundra, if I'm pronouncing it correctly, into strong passwords first. New password, let's include some uppercase letters, lowercase letters, and digits and special characters. We are going to do the same for the next account. And that is out of our way. We should also delete these two accounts, Joseph and test number 1. And there we go, that's it for this task. In the next one, we have to review sudo permissions for users and specifically revoke all sudo privileges from user Mundra. And the user Mary should be able to run this command as root. And when doing so, she must not be asked for her password. Assign the corresponding sudo privileges. Now, when we are editing this specific file, we need to make sure the syntax we are using to add anything to the file is correct. Otherwise, it will break the file and can cause a lot of problems in the system. Okay, let's go back to the terminal. I'm going to use this special command called sudo vsudo. We are going to scroll down all the way to where Mundra is, right here, and we're going to comment that out. And we're going to add a new line for Mary and give special access to that specific path, which is this right here. And we are going to set, and we're supposed to set a condition where she must not be asked for the password when she is trying to execute this particular command. Let me double check this. Cool, looks good to me. So let's exit this by saving the changes. To verify this, let's test that out. Let's test that command. Yep, it worked without any issues. And onto the final task of this room, it says in the detection results, the following database ports were accessible from the network. 2 TCP ports, one is for MySQL and the other one is the Redis server. So basically there is no need to expose the database ports given here, because they are both only required locally by the server's apps only. So we are supposed to modify the MySQL server configuration to bind the port 3306 to localhost only. And we are supposed to modify the Redis's configuration to bind the port 6379 to localhost only. Okay, so I'm going to exit from this, and we are going to first of all attempt to change the bind address in MySQL config to the localhost only. So the path should be located at here. Cool. If you take a look at here, like the detection report says, it is being set to accessible from the entire network. We are going to change that to the local host only. Save those changes and exit the file, and next we are going to restart the MySQL service. Okay, in the second part of this task, we are supposed to navigate to redis.config. There we go. Just like the detection report says, it's set to access from the entire network. We'll change it to localhost only. Cool. And we should restart this server as well. Done. So just like I said before, guys, at the end of each task, you should use get dash flags to weave all the flags for each particular task, and it will reveal each and every flag for each task that you are supposed to find in order to complete the room. So there we go. We have arrived at the end of the video, and this room shows the damage an outdated and misconfigured server can do. I encourage you to implement best security practices and harden your servers. Otherwise, you or your entire organization could be in great danger, and you wouldn't even know until you are compromised. I hope you learned something valuable out of this video, and if you did, make sure to like and comment on this video, and do not forget to subscribe as it will help this channel grow. Thank you so much for watching. I'll catch you in a future video very soon. Until then, take care of yourself and take care of each other. Peace.